Hi everyone, welcome to Gig24. My name is Shatrang and I welcome you all in this series of Learning Java. We will be covering everything about constructor. What is constructor, why constructor is required, why we need constructor, what are the different types of constructor. Along with constructors, what are some other things that we uses, we will be talking about them also. We will be talking about this keyword, we will be talking about super keyword, we will be talking about a static keyword. We will also be looking at constructor overloading, constructor overriding, and along with that we will also be learning about method overloading and method overriding. And after the end of all the types of or all the different types of constructor, we will also be discussing about the interview question that generally get asked in the Java interview. So without further ado, let's quickly get started. So first thing first, let's talk about what is constructor in Java. So in Java, constructors are special methods used to initialize objects. They have the same name as the class and no return type. Well, this definition holds a lot of information and in the entire video we will be discussing about them only. Let's start with the types of constructor and the definition will eventually be clear to you. We have different types of constructors in Java. So the first type of constructor is the default constructor. We have no args constructor, that means no arguments constructor. We have parameterized constructor. We have static constructor. We have static constructor. Then we have copy constructor. We also have something called as constructor chaining, and I think we should use constructor instead of constructors, but that's fine. I'll just do a quick refactoring. And constructor chaining, we call it as chained constructors. Chained constructor. So let me write it here. And we also call it constructor chaining. After that, we will be also talking about private constructor. So private constructor. So these are all the different types of constructors that we have in Java, and all of them are really simple to understand. We just need to tweak one or two lines and we can easily understand what are the different types of constructors and how to create them. So let's start with the very basic, the default constructor. To do that, we need a class. We already have one class, that is main, and inside of this main class I have a public static void main, and in this we are printing constructor in Java. Let me run this current file and see if everything is working. We can see the output, that means we are good to go. By the way, I'm using IntelliJ IDEA. If you want to use any other IDE, feel free to do so. You can use NetBeans, you can use Eclipse, even you can use VS Code or any other text editor. That's perfectly fine. Let's create a new class here, and I'll be naming this class as let's say we will name our class as person. And this person class will going to be our class where we will be creating different type of constructors. A person contains age, every person has an age, and every person has some name. So we have created two variables here, integer age and a string name. These are called as member variable or instance variable. These belongs to the instance or object of this person class. I hope you are aware of it. I want to make an object of person class. So let's get back, and here what I can do, I can easily create an object using person, the class name, the object or the name of the object. I will name it person1 equals to new keyword, and we have to write person class and put the pair of parentheses here. Now this reminds us of function invocation, or in terms of object-oriented programming, we generally call functions as methods. So this reminds us of method invocation. Yeah, that's exactly right. We will talk about that in a bit. But for now, let me set the values for age and name. So person1 will have some name. Let me set name to be, let's say I will give my name, and person should also be having age. So let me give some age. And then I will also be printing these two values. So let's check whether the person1 got the name and age or not. So to print the name, we will write person1 dot name, and to print age, let me copy this in the new line, let me paste it, and we will say person1.age. I'm hoping that you are already aware of what is object and what is class in Java. If you are not aware of this concept, then I would recommend you to go and check some other videos where you will get a basic understanding of how Java works, what is classes in Java, what are objects in Java. Because in this video we are solely focusing on constructors. So let's run this code and see what happens, what we see is in the console or in the terminal. So here we can see constructor in Java. This is our first system.out.println line. That's fine. After that we created person1. This is our object and we set the name of the object as Shatrang and age is 21. And then we printed it and it is there. Now let's get back to this class. Here we don't have anything special. But you might be noticing that we have one line here. If I zoom it a little bit more and give some space here to just focus this particular line, and you will notice that here we have person. This is perfectly fine. If I control and click or command click on this particular person, it will take me to this class. So yeah, this is our person class. Person1 is the object name. Just like we name our variables, this is the object's name. New is a keyword in Java. We know that, and that's perfectly fine. And now here we have a method invocation. What is this? We have no method like this in our person class. We haven't created anything like this in person class. So how we can call this? How we are calling this particular person method here? And this is exactly the right time to talk about constructors, because this is not a method. This is what we call as a constructor. And as we discussed in the definition of constructor, constructors are special methods. That means constructors are nothing but methods, but they are special. They have same name as the class name and no return type. They have the same name as the class name. We have person class and the name of this constructor is also person. But you might be noticing that, hey, we have no constructor created here. So how can I call this constructor here while creating the object? So here we can say that this is where Java comes into the picture, and Java says that, hey, if you haven't created any constructor in your class, I will create one for you. This particular expression is called as constructor invocation. We are invoking a constructor, just like method invocation, but we have no constructor written in the class. So question arises from where this constructor is coming. We are getting this from Java. Java says, hey, if the developer has not created any type of constructor in the class, I'll create one for him or her. So Java created one person constructor like this for me. And this is what we called as default constructor. And this is perfectly fine even if we omit this, because default constructor is default, Java gives it, and here we can use it. So this is the first type of constructor which we already have covered. And you might be saying, hey, we haven't created any constructor, right? Yeah, we don't need to create default constructor because default constructor is default. It will given to you by Java. We just need to invoke it like this. So whenever we are creating an object, we are invoking a constructor. Now let's jump to the next type of constructor, that is no args constructor, no arguments constructor. As we said, constructor name should be same as class name, so we will write person. It will not return anything, so here's the reason I am not writing any return type like void or integer, because constructor cannot return anything. So we are removing that return type. So person is the constructor, and this is no argument constructor because we have no parameter list here. We are not taking any parameter. While calling this constructor, we are not passing anything here. I hope you know about methods, right? If you know about functions, in function, whenever we pass something here at the time of calling that particular function, we called as an arguments. In Java also, we call them as arguments. You are arguing with your function that, hey, this should be the value which you need to receive. And here while receiving it, we call it as parameters. We will discuss about them soon. But right now we have no parameters, hence we call them as the no argument constructor. So you might be wondering, hey, there is no difference between a default constructor and a no argument constructor. Both are same. And yeah, both are same. Both have no differences. But the thing is, default constructor looks like this. But if you want to print anything inside of it or do anything inside of this default constructor, you need to make one. I hope that makes sense. Default constructor given by Java, it is invisible to you, it is transparent, it is something that is there, you have to believe on Java. But if you want to do anything inside of this default constructor, you have to do this. You have to write this line of code. You have to create your own constructor, or you have to create your own default constructor. And inside of this, I can write sout default, or better we should call it no args, args constructor, truct or constructor, and let's save it. If I go back and run this file, you might be noticing that constructor in Java, this is our first line, is printing. After that, we have this particular line getting printed, and this is what we have printed, no args constructor. That means a no argument constructor has been called. Who have called it? We have called it here, remember? And after that, we have printed these two lines, and here we have the values of the name and age. So that is the second type of constructor, the no argument constructor. You can make your own default constructor. When you are making your own default constructor, that will be called as no argument constructor, right? So default constructor and no argument constructor look same, but the thing is, we call it default if you are not creating any constructor in your code. If you are creating a default constructor, it will ultimately become no argument constructor. I hope that makes sense. Now let's move on to the third type of constructor, that is parameterized constructor. If I can spell it, or let me just copy it and paste it over here. Now parameterized constructor is also same. While creating constructor, remember one thing, you don't need to change the name. Every type of constructor should have the same name as the class name. To make a parameterized constructor, we have to write name of the class as it is, person, then pair of parentheses and curly braces. Now here, because it is parameterized, that means there should be parameters, just like we do accept parameters in methods. So we can accept two things. We have two variables here, age and name. So let me accept a for age and string n for name, and let me just print them out. Age in double quotes, age is age plus a space plus name is I can say plus name, or n, basically not age, n. So age a n for name, and let's run this code. But before running this code, we need to make sure that we are calling this parameterized constructor. Right now, we are not calling this parameterized constructor here. We are calling the default or no argument constructor because we haven't passed any constructor here. If you do control or command click on this person, see where the control is taking us. The ID is taking us to this no argument constructor. To call this particular argument constructor or parameterized constructor, we need to pass arguments. So whenever we call a function, by the time of calling a function, when we pass value here, like age of 12 and name of my name, for example, these values are called as arguments, and while receiving these two values, we call them as parameters. One more way of remembering argument versus parameter is, while calling this person constructor, or even if you are calling a method, you are arguing with Java that, hey, I want to set value of a to 12, I'm arguing. I want to set value of n to this, I'm arguing. I am saying that please do this. While receiving, you cannot argue, you just receives it. Hey, whatever comes, okay, I'll take it. So this is parameter, and because you are arguing that, hey, this should be the value, this is arguments. I hope this makes sense now. Now, just to make things little simpler in the beginning, I'm removing these two lines, and I'm also removing these two system.out.println lines. And let's run our code. When we run, now you can notice that we have this particular constructor called. Even if you go and do a control or command click on this person, now control or IDE is taking us on this parameterized constructor. So we are getting the point. To call a parameterized constructor, we have to pass parameters. This function should accept parameters, or this special method called as constructor should accept parameters. And we have printed them as age of 12 and name as Shatrang. So we are getting the print statement over in the terminal. And before finishing this topic about parameterized constructor, let me just do one thing. Instead of just printing the value, what we will do, whatever value we are getting in the parameters, let's set these value in the member variables. So what we can do, we can write age equals to A and name equals to N, semicolon. Let's say if we do this and if we go back to our main function, and if I uncomment these two lines, what do you think what will be the output? If I run this code, you will notice that hey, we are getting Chitrang and 12, and from where we are getting them from here. So the person object or person1 object has now got the value name as Chitrang and person1.age as 12. We were doing the same thing here as well, right? If you notice, we were doing the same thing here as well. Why do we need a complex mechanism like this? Or why do we need to call constructor with some values and set the values like this inside of the constructor instead of directly setting values here? We can do the same thing here as well, like this. We can set value of name and age using this syntax. Why do we need constructor? So the answer of this question is very simple. Look, in this line, while creating person1 object, you are giving value to the object, like you are setting the name and age at the same line. And this is what we require. This is what we require. If someday you forgot to set person1.name and person1.age, that means you are not initializing your object properly. That means your object will not have the value you desire. And here comes the constructor to save us. Whenever we want to create an object and set the initial value, we use this constructor. It is better to use the constructor because as soon as you create an object, you are setting the value of the member variables or you are initializing objects. So this is one of the very common reasons why we want to use constructors. Let me remove these two from here and we talk about some more things, some more important things in the constructor. If I command click or control click, I'm getting to this particular constructor. This is, we know it is a parameterized constructor. Now, you might be noticing or you might be wondering that the name of our variable here is age and name. But why we are receiving A and N, why can't we make them age and name like this? And instead of setting age like this, A, I will replace it with the variable which we have here, age and name. Will it not work? Yes and no at the same time. This will not work because now Java compiler or Java is confused. Java is saying, hey, this is name, which one is which? This name is this, or you are referring this name as this name which you are getting in the parameter. And this confusion of Java can be solved using this keyword. So we can write, hey, this.age, that means the age variable which we have here, we are referencing it using this. If you command click on this now, the IDE will take you to this variable. So this age is equals to the age you are getting in the parameter. And this dot name, that means the name which we have here in the class, the variable name, is equals to the name that you are getting in the parameters. So now let's talk a little bit about what is this keyword. So this keyword is a reference variable that refers to the current object. It is commonly used to differentiate instance variable from method or constructor parameters, but has several other use cases too. So as we have seen in the definition, we are using this to differentiate between the member variable, that means age and name. These are two member variables, and we are differentiating them with the parameter variable, the instance variable, that means this particular parameter age, and this age is different. We are calling Java, and the confusion of Java is now resolved. But this can be used on several other places as well, and in later section of this video we will learn about them as well. No need to worry about that. But now we have talked about three types of constructor. The default constructor, which doesn't really exist, Java gives us. The no argument constructor, which is similar to the default constructor. Just the thing is, if you want to write something in the body, you have to create your own constructor. And the no argument constructor is similar to the default constructor, right? Okay, let me remove it. And then we have parameterized constructor. In the parameterized constructor, we have parameters and we can use these parameters to set the value of member variables. If you have understood all the things which I have said till now, then let's revise what we had learned in the definition. In Java, constructors are a special method used to initialize objects. And what we are doing here, we are initializing our object. As soon as we are creating a new object, we are initializing them with some values. And yeah, p1.name, p1.age getting initialized with 12 and my name, right? And yeah, we are fulfilling the purpose of constructor in this example using parameterized constructor. Let's move on to our next type of constructor, the fourth type of constructor, that is copy constructor. So what is a copy constructor? By definition, a copy constructor is a constructor that creates a copy of another object of the same class. Definition is little heavier, I know, but I can explain you this in a very simple way. Let's say we have one person called person1. I told you that, hey, you are a developer, you're a smart Java developer. I want you to create another person named person2. This object, I want you to make this object person2. This person2 should be the copy of person1. Can you do this in Java? No, you cannot do this in Java. Maybe a language like JavaScript will allow you to do this, but no, this is something which is not possible, right? So how you will do this? You can say that, okay, this is very simple. You want me to create a person2, and this person2 should look exactly like person1. I can easily do this. I will just copy and I'll just paste it. I'll rename this to person2, and that's all. We are done, right? We are done. We have person2 with same name and age. Fine. We have a better solution. By the way, this is also a solution. This is perfectly fine. But Java gives us one very quick and easy way to do this. Java says, hey, you can do this thing very easily using a feature called copy constructor. So copy constructor is not something difficult. What we are doing, we are making a constructor. Constructor, the creation of constructor is same. We have to give the same name as the class name. So our class name is person. The constructor name should be person. And here, instead of receiving integer age or string name, what you can do, Java told us, hey, just remove this, and instead of that, just take an object itself. How we can do that? Just take person object, person p. You will say, hey, what is person p? So think of it like you are taking a variable of type integer, and the variable name will be here, instance variable name will be age. So what is integer here? Integer is a pre-built data type in Java, right? But instead of that, I'm saying, hey, we have a user defined data type named person. So the type of this p object is person. That's why we have written person. If we wanted to receive a string, then I might write here a string. But because we want to receive person, because we want to receive an object that is of type person, I have written person. And now instead of doing this thing, what I can do, I can say, hey, person2 equals to new person, and just pass person1 here inside of this copy constructor. If you command click over this person, let's see where it takes us. Okay, it is taking us to this copy constructor because Java knows, or this IDE knows, that hey, this is taking an object, this is taking an object. So we have to call this where we are receiving an object. All right. And how we can set the variables now, how we can copy our variables now, it is very simple. We can use this .age, and we can take whatever we have in the p.age and this .name coming from p.name. Save it. And just to prove my point that we have a person2 that is looking exactly like what we have values in person1, I'm just copying and pasting them here. And let's say person, instead of person1, I'm printing person2.name and person2.age. Let's run it and see what happens. Okay, we have identical objects. We have Chitrang and 12. So we have easily copied. And the next type of constructor is static constructor. Okay, before moving to static constructor, this is important to know that static is a keyword. If you know about a static, and if you understand what a static variable, static methods, and a static block is in Java, then you can skip this section. You will get the timestamps in the description box. You can easily skip this section. But if you don't know, I would recommend you to just keep watching, because now I will be discussing about static and then we resume back to our constructor, or then we will learn about a static constructor. If you don't know about a static, it doesn't make any sense to learn about a static constructor, because there is a prerequisite, you should know static, right? So let's get to the main and learn a little bit about a static. I'll be creating a new class. I think that will make more sense. So let's create a new class and let me name it as static example. And in this class, we can zoom it a little as well, or maybe just make more space here so you will get a clear view. Let's talk about a static keyword first. The static keyword in Java is used to indicate that a member variable, member method, or block belong to class rather than a specific instance of the class. This means you don't need to create an object of the class to access the static members. Static members are shared across all instances of the class. And I know for beginners, these definition doesn't make any sense until we do some code. So let's create a code. Let me create another new class. I think a static example should not be the class name. Let's create a new class and I'll name this class as student and hit enter. Now let's say that we have the student class in our project. This is student class. We will take it very simple. We will not be taking any complex examples, so don't worry. This is student class should have some variables, like we should have name of the student. Every student should have some name. Now after name, we can have one more variable. Let's say we need one more variable called school code. So every school should have some code as well, correct? Every school has some code. So the school code is primary, like every school has one school code, and that school code will going to be same for every student. Let's say using this class, student class, we can make 1000 student objects. Each of the object will have a different name. Each of the student who are getting enrolled in our school may have different name. If we have several other properties like age, everyone will have different age, have different phone number. But let's say because we are taking things very simple, everyone has a different name. But will everyone have different school code? No, because school code is something that everyone will share because they all are in the same school eventually, right? So we will say that, hey, school code is something that will remain same. Even if the student is in nursery class, the school code will going to be same. Let's say 1, 2, 3, 4, 5 is the school code. So the school code for nursery going student will be 1, 2, 3, 4, 5. The school code for 10th students will be 1, 2, 3, 4, 5. And school code for 12th going students will going to be same as well, 1, 2, 3, 4, 5. So we can say, hey, if that will going to be same for everyone, let's make them static. How we will make them static? Using a static keyword. So let's just write static in front of this variable, static integer school code, and the value of this school code will going to be 1, 2, 3, 4, 5 for every object. Alright, let's go to the main class now. I am commenting out everything whatever I have right now, and let's just give some space. So we have, okay, let me give spaces here, and now let's create an object of this student class. How you will create an object? Simple, you will write a student, let's say student1 equals to new student, and we are invoking a constructor. Now you can see constructor everywhere, right? You are invoking a constructor, but hey, we haven't created any constructor in the student class. Don't worry, you have a default constructor. Java will create a default constructor for you. Remember, if you want to print something or do something in the constructor, then you can make your own constructor. That's not an issue. You can say, hey, I will be creating my own constructor, student constructor, like this. So this is also a default constructor, but you have created it, so you will name it no argument constructor. But we don't need this right now. Let's remove it, or maybe let's keep it. What we will do, instead of making it as a no argument constructor, let me set the name. Okay, we have to set the name. So let me say our constructor, because we are using, so let's utilize it, right? Because we have written it, so let's utilize it. So we will take name from this constructor, and we will set the name of the member variable using this.name equals to name. So we are setting this name to the name which we are receiving in the parameters. Now there is one related problem, and the problem is you are calling the default constructor, but here we have no default constructor in the student class. You will say, hey, we don't have any default constructor. You just said that Java gives us default constructor, but I've also said that if you create any type of constructor in your code, Java will say, hey, developer has already taken the thing in his or her own hands. He is already creating constructor, so he is responsible for the constructor creation. I will not provide any default constructor. And hence Java is not providing any default constructor. Now what we can do, we can make our own default constructor. There is no issue in that. So I will say I'll be creating a default constructor, so I will not get that error. So now the error is gone and we can call the default constructor. I hope this is making sense. If it is not making sense, you can comment down in the comment section. You can ask your doubts. Now let's go to the class again. We, instead of calling the default constructor, let me give it a name. So let me call the parameterized constructor. The name of this student will going to be my name, Chitrang, and I'm setting this name. Okay. And now we can also remove it. So as I've said, hey, you are not calling default constructor. If you're calling default constructor, then it is required. Then you have to write it. But if you're not using default constructor, you're writing parameterized constructor, you're calling parameterized constructor, then you can remove it, right? There is no usage of that. That will not throw an error. And here, instead of creating another constructor, I'm creating a new method. This time I'm creating a method. So let's say display. This display will be displaying simply my name. So let's say name is equals to plus name plus I'm displaying school code as well. SCHOOL school code will going to be the school code. Save it. Let's get back to the main class and let's just call our, and how to call the method, student1 dot we get display, and this is how you call the method which resides inside of our class. So we have used object, we have created an object, set the name, and we are doing display. We are calling the display method. Let's save it and rerun. You can see that, okay, there is no space because I haven't given any space. So I should give a space here. And now if I rerun it, you will notice that name is Chitrang and school code is 12345. Let me create few more objects. Let's say this is student 2. Name will be Rohan. Student 3. Name of this student is let's say Ram. And now if I do student 2 dot display and student 3 dot display and run it, so here the school code is same. You can ask, hey, what happens if we don't use a static here and if we don't do it like this, and if we just go and instead of doing static, we will just pass number 1 2 3 4 5 and we will pass this school code in every object creation or calling of the constructor. And here instead of just receiving the name, we will also receive the school code, that is integer code, and we will set this dot school code equals to code which we are getting, and that will also work perfectly fine. But in this we are increasing our burden, we are increasing our number of parameters, which we should not do, right? If something is a static, just make it a static. And one more thing about a static that is very important to know is a static variable does not belongs to object. If I do student1 dot display, I can say that student1 dot. When I write dot, I can see all the methods and variables available inside this student1 object or student class. I can see the name, I can see the display. Dot equals, these are all the pre-built functions or pre-built methods, but I cannot see school code. If I do school code, I cannot do this. I cannot do school code. I cannot change school code like this. What Java is saying? Java is saying static member access via instance references. So we cannot use instance to change or to refer the static variables. And you might be wondering, hey, what is the sense? This is confusing. I will say, hey, remove everything and let me explain you. Let's say here you want to system.out.println, you want to print something. What do you want to print? You want to print, let's say we are creating a student1 and you want to print the name of the student. So I can say student1 dot name and let me just run it and we are getting the name. Now if you want to print the school name, how will you print the school name? This is a problem, right? So no, there is not a problem. As we said in the definition, static keyword in Java is used to indicate that a member variable a member method or a static block belong to the class rather than the specific instance of the class. That means to access this particular school code, I just need to use this class name. So I can do student dot school code. You can notice that if I write a student dot, then it is saying that, hey, school code is there. It is a class. And yeah, you can use a school code directly using the class name. 1, 2, 3, 4, 5. This is the specialty of static variables. If you want to update, you can do something like, let's say 4, 5, 6, 7, 8 and semicolon. And now you can see that the code is updated. For everyone, it will get updated. Let me just do, let me uncomment them and let me put these lines after doing the updation. Remove this and let's rerun it. You can see that only one line of code at one place we have updated the school code for every object. That is the power of a static variables. Now that's all about a static variables. I hope you get the point. Static variables is not something that belongs to the object, but they belongs directly to the class. They are something that is there for the class. Now similar to static variable, we also have something called as a static method. A static method can be called without creating an object of the class. A static method can only access other static variables or methods. They cannot directly access instance variables or methods. We'll now create a static method. How we can create a static method? Simple, using a static keyword. Let's say we will create a method and the name of the method is add. We will be adding two things, A and B. We will be adding these two parameter variables and we can return A plus B, the summation of A and B. To call this add, we don't need to create an object. By the way, normal methods can only be called using the object. We made an object student1 and then called the display method. We cannot directly call display like this. Every variable, every method, if it is not a static, belongs to the object. This is the object. And this object will say, hey, my display method should be called. This will say, hey, my display method should be called. Student3 will say, hey, I am a student3 and my display method that is different should be called. But in case of static methods, you can call them directly. Like just write add and they will work. I want to sum 2 plus 2 and this will work. This is giving an error because Java still don't know that, okay, you are calling add, but where is add? So you have to tell that add belongs to what? Add belongs to student. Just like we were referring our school code, we have to say student.add. And let me bring both of them closer so we will get a basic understanding. We are getting some error here. So it is saying student add is ignored. That means the result which we are getting after this summation of 2 plus 2, we are not storing it anywhere. So let's store them. Let's say result is equals to student.add. So you can understand here that student add is something, or add method is something that belongs to student only, and the school code is also something that belongs to student class instead of student class objects. And now let's just print this as out and print the result. Let's run it again. Now we have 4 as a result of 2 plus 2. So this was the concept of static variables and static methods. Now there is one more thing remaining in a static, and that is a static block. So let's discuss about that now. A static block is a block of code that gets executed once when the class is loaded into memory, before the main method or any object creation. It is used to initialize the static variables. Let's get back to our student class. We already saw static variable, static method. Now let's see static block. A block is something which looks like this. This is a block in Java. And if we make this block as a static, this is a static block. It is very simple, right? And what we can do inside of this runs even before our main method runs. This piece of code will run even before our objects will get created. One thing to mention here, that static block is used to instantiate the static variables. Like for example, right now I just did 1, 2, 3, 4, 5 here. I just instantiated my school code here, but I can instantiate my school code here too. Like I can make school code equals to 1, 2, 3, 4, 5, and this is the instantiation. One more thing to notice, that static block can only access static methods and static variables. It cannot deal or it cannot handle other type of variables like name. It cannot deal with name. It cannot deal with other type of methods that are not static. So static block will only work with static variables and static methods. And just to prove my point this works, let me go to the main again and let me run this code. Still we are getting the same 4, 5, 6, 7, 8 which we have set here. Okay, I think this is something which we have changed here, so we can remove this and let's say if this works or not. So yeah, it is working. 1, 2, 3, 4, 5 is working perfectly fine, and we can see that school code is instantiated in this static block. We can do the same thing here as well. We were doing this here only, so why do we need a separate concept like a static block just to instantiate a school code? We can do it right here also. So the answer is very simple. When you want to do a complex instantiation, like when you want your school code to have some complex calculation before assigning a value. Let's say I don't want to give school code this is static 1, 2, 3, 4, 5 number. I want you to assign a random integer. How you will assign a random integer? You can do some coding like this. You can use math.random. So let's say we are using math class from java.lang, and .random will create a random number, multiply by 100. So let's say multiply by 100, and we will wrap them inside of the parenthesis, and I'll just cast it to integer, and this will be my school code, right? So school code is a random integer, random number which I don't know. Math.random gives me a random number, and I'm initializing like this. And if you want to do some API calling, if you want to perform some complex logic which cannot be done in a single line, then you can use a static block, and then you can initialize your values of static variables. Let's say if we go back to main, and let me just test what happens. We are getting a random integer of 67 because we have multiplied it with 100, so it will always remain within the range of 0 to 100. And if I just run it again, it is 15. Run it again, it is still a random number 23, 57. So this is how it works. I hope you get a basic understanding of static variable, static methods, and a static block. Now I'll remove this because we don't need it anymore. And now we have to focus back on constructors because this video is about constructor, believe me. And I'll just again make them uncomment, remove the extra spaces, and reopen the person class. Inside here, we were talking about a static constructor. Now, after discussing all these things about a static, I'm a little bit afraid to tell you this, that Java does not support a static constructor directly. But yeah, there is a way which we can use to simulate this behavior. There is a way which we can use to simulate and create a static constructor. But as I said, this is just a simulation. There is no real or direct implementation, and Java does not give the static constructor directly. But how we can do the simulation? This is something which we have already seen, but let's do it again just to make things clear. Let me say, if I have to deal with a static constructor, I need a static variable. In the person class, we don't have any static variable. So let me create a static variable here. Let's say I will be creating a counter. So we will say static integer count, count, count. And this count is what? This is a static variable. I'll go back down here in the static constructor. Let me say I need to initialize this static count. We were doing the same thing for these two variables in the parameterized constructor. We were initializing them. We were initializing, or we were copying the object in the copy constructor. In the static constructor, what we will do? How we will initialize? We know that we will use a static and block. We will use a static block to initialize the value of count to maybe 0. And that's all. That's what we call it as a static constructor. And I hope you are happy about it. I don't know if you are happy or sad about it that I talked that much and I told you this much about a static and then I showed you this. But yeah, this is something that was important, and a static constructor is nothing but this static block. And that's all. Now let me quickly recap what is a static block. A static block is a block of code that is executed once when the class is loaded into the memory by the JVM. It is primarily used to initiate or initialize static variables or perform one-time setup operation for the class. Now let's talk about the next type of constructor, and that is chained constructors. What is chained constructors? Chained constructors are really simple. Chained constructor is like calling one constructor from another constructor in the same class using this keyword. So we have already seen that this is used to do what? This is used to differentiate the member variable and the instance variable. But now we will use this to call another constructor, and we will see how. Create a chained constructor. We don't need to actually create another constructor. We can do the chaining within these constructors only, which we already have. So here we already have a class person. This person class has two variables, age and name, and a static variable. So you can keep it or you can either remove it. That doesn't really matter. And here, let's say we have a default constructor or a no argument constructor. Okay, sorry, this is our default constructor. Let me remove this from here so we will have less confusion. We have a no argument constructor. Right now we are just printing no argument constructor. Let me remove this print statement. And I will go to main, and instead of calling this parameterized constructor, let me cut and let me call the default constructor. I hope by this time you are aware of what is default constructor. We are calling without parameter. That means we are calling no argument constructor. If we do control click or command click, it will take us to this particular no argument constructor. And now from this constructor, I want to call this parameterized constructor. How is it possible? Is it possible or not? Yes, it is possible. We can use this and we can call our parameterized constructor like this. And that's all. You can call any type of constructor using this, because this knows what is the current instance. This knows this entire, you can say this entire class and all the objects or constructors available in this class. And by the value, we are passing 12 and the name. So our constructor knows, or Java knows, that hey, this is calling this parameterized constructor because age is number and we are passing number, and a string is name, or name is a string and we are passing a string. So we have to call this. Let's see if this works. From here we are not calling. Okay, let me remove this person too as well. We are not calling any parameterized constructor. We are not passing name. We are not passing age. Let's see what happens. Let's run this file. And we are getting the same result. We are getting Chitrang and 12. How? If we change name to, let's say, any other name, Alok, and rerun this file, the main file, Alok and 12. How this is happening? Because we are calling the default constructor, but in the default constructor, this is calling the parameterized constructor for us. So this is called method chaining, or not method chaining actually. This is called as constructor chaining. One thing to remember here, that if you want to use a code like this, if you want to use this to chain, this line should be the first line of your constructor. You cannot do s out, like you cannot system.out.println something and then you will be calling this. This has to be the first line. If you hover over it, you can see call to this must be the first statement in the constructor body. So you have to Control X or copy it and paste it at the top. So that's how it will work. And that's all in the chained constructor. By the end of this section, we have already covered a lot of things about constructor. We have talked about default constructor, no argument constructor, parameterized constructor, constructor chaining, copy constructor, and we also saw a static keyword, a static variable, a static member, and a static block. Now in this section, we will be talking a little about super keyword. Because we are already talking about constructors, it is important to learn super right now. In Java, super is used to refer to the immediate parent's class constructor. It allows the child class to initialize fields to perform setup defined in the parent class. There are some key points about super. Number one is the purpose. It is used to call the constructor of the immediate parent class. It is often used when the child class needs to use initialization logic defined in the parent class. Number two is the rule. Super must be the first statement in a constructor. If you don't explicitly call super, the compiler adds a default call to super, the no argument constructor of the parent class. Usage. to ensure that the parent class constructor run before the child's constructor. So let me do one thing. We'll make more classes and understand super by doing some code. I'm creating a new class. Let's say I'm creating a class that will be our parent class. I'm creating a class named animal, and this class will be the parent class. Now animal class can have a child class. We'll make another class named dog. Dog is an animal, and we can say dog is the child class, so we can extend the capabilities of its parent in the dog. We will extend animal, and this will make the dog class as the child class and animal as the base class. We call base class, parent class, super class, whatever you want to call it. Animal is our super class. Inside of the animal class, let me make few variables. All the animal have some name, so we are creating a variable name here. I am inside animal class, so I have to create constructor using the same name of the class name, and animal is my constructor name. After this, inside of the animal or inside of this constructor, I will be receiving string name, string name, and let's just set this dot name, assign the name which we are receiving here in the props. And we are getting some related issues because we haven't called it. That's perfectly fine. We'll look into it. Let me do one more thing. I'm just doing a system.out.print or sout in short. Let's say we are inside animal constructor, or we can say animal constructor called, and we will also print the name plus name. After doing this, let's go to the dog class. Now you will notice we already have a red line here there as an indication that there is no default constructor available in the animal. Whenever we have a child and parent relationship in Java, that means whenever a class extending another class, the superclass or the child class should implement or should call the constructor of the parent class, that is animal in our case. How we can call animal's class constructor here in the dog class? We can do it using super keyword, and that we will be looking in a moment. But right now it is saying that there is no default constructor available in the animal, because we already know that if we create any type of constructor, default constructor will not be provided by the Java. If I remove this, then there will be no error, and you can imagine that default constructor is there now. Or even if we create our own default constructor or our no argument constructor like this, there is no error because Java knows now we have a default constructor or a no argument constructor. Now we have no error here because Java will call the default constructor for us. But we need to make our own constructor or a parameterized constructor to set the value of name. I can remove the default constructor and it will again throw an error to us that there is no implementation or we are not calling constructor of the parent here in the dog class. So we will fix it. Let me make some variable here as well. In the dog class, we will create a variable named integer age. This will be the age of our dog, and we will make a constructor here too. This constructor is the child's constructor. We know that if we are creating a constructor, then the name of the constructor should be as same as the name of the class, and this will also be a parameterized constructor. In the child class, we will receive two things. First, we will receive the name, and second, we will receive the age. Using the age, we can easily set the age that is there in the member, or that is the member variable, using this dot age, assign the age. But what about this name? We are getting some error that there is no default constructor available in animal. That we got it. In child class, we have to call the parent's constructor. Now at this moment, we know that we have one constructor and we can call it by ourselves or manually. How we can call the constructor of parent class? Simple, using super keyword. And using super, we need to pass our argument because we are receiving argument here. You can consider super just like what we did a few minutes ago using this keyword. When we want to call another constructor within the same class, we uses this. But when we want to call a constructor that is not in the same class but in the parent class, we use a super. Inside of the super, I can pass the name as it is. So if I pass the name, this super will call this particular constructor which is there in the animal, and there is a parameter that will receive the name and set the name in this variable. I hope that makes sense. Now if we go to the dog class, we are not getting any error and we can easily run this. How we will run this? Before running it, let me do a s out really quick and say dog constructor called, and we will also print the age. So age will be the age. Save it. Let's go to the main. For now, I'm removing everything whatever we have inside of the main, and let me create a constructor. Oh, sorry, let me create an object of the dog class. So let's make our dog. I will say the object name will going to be dog1 equals to new and dog. This is constructor invocation, and in the constructor invocation, because we don't have any default constructor, we are getting an error here that is saying your constructor requires name and age. So we can pass the name and age. Let me give our dog a name, let's say Tom, and age of our dog is 2 years. Save that. Now if I run this current file, we are getting the output in the terminal, and here we can see that animal constructor called and name is Tom. So the control went inside the dog. Here in the dog, super keyword called our parent class constructor. This set the name whatever we have given, and we have a string name. So this will set the member variable name, and we are printing. So this print statement is getting printed here. After invoking the parent class constructor using super, we are setting age and we are printing dog constructor called age is 2 years. So we are getting that over here. And by the way, this super keyword should remind you that super means calling the super class. Parent class in Java also called as a super class. Sometimes you often call it as a base class. So super keyword simply means calling the super class. And this should be the first statement in your constructor. We cannot place it like after doing this .age, we cannot do this. And if I hover over it, it will say that call to super must be the first statement in the constructor body. So we will do that. Control X and paste it again. One more thing that is very important to note here, that super is something which we are calling here explicitly or manually. I will mention that we are manually calling super. But in most of the cases, when we don't have a constructor like this in the parent, what Java does is Java automatically calls super for us. Here in the animal class, we have no constructor created. That means we will get a default constructor by Java. Yeah, we have talked about it a lot of times now in this video, that if we have no constructor created, let me completely remove it, we will get a default constructor. If we don't call super by ourselves, Java will make a super call. Java will put this line for us. And in this case, super is calling a default constructor of animal class. Let me create a no argument constructor here in the animal class. And let's do a simple system.out.println, and we say default, or let me name it properly, no args constructor inside the called inside the animal class. Let's save it, and I'm removing this super keyword. If I go back to my main class, let's remove this person class from here for now, and let's run it. We have a line, we have a print statement executed that no argument constructor called inside the animal class. We haven't called super in our dog class. So we can assume that super is here and Java automatically called the super for us. We don't have to manually call super until or unless we have a default constructor in our animal class. If we create any type of constructor in our animal class or a parent class, let's suppose we are receiving name here, and instead of printing anything, I'm using this .name assign name and semicolon at the end. So in this case, because we are already creating one type of constructor, Java will not provide this default constructor, so we have to create our own default constructor, no argument constructor. Now in this case, we are not getting any error because we are calling super and super will call the default constructor. But if we don't have a default constructor or a no argument constructor, Java will say, hey, you have to call either you have to create a default constructor or call the argument constructor. Because you have an argument constructor, you're not passing arguments, so I can simply pass my arguments. But if I want to create another constructor in this dog class, let's say I'm creating another constructor. In this case, I'm receiving a value, for example, count. I'm receiving a count variable. Here in this constructor is different from this because here we were receiving two different parameters, and here we have just one single parameter. If I do s out and I'll say count assign or count equals to plus count, here we are not getting any error, but you can notice here we have a red line under our class name. What do you think what will happen if I go and if I create a new dog object? Let me create a new dog object, dog2 equals to new dog, and instead of calling this parameterized constructor, I will be passing 12 as my argument here to call this particular constructor. Now if I go and if I run this file, we will get an error, and here we have the error. What it is saying, constructor animal in class animal cannot be applied to given types. So if I simplify this, what it is basically saying and why we are getting this error, because whenever you are creating a constructor and if you have some parent class like animal in this case, you have to call super. You have to call super. Either you call it or either I'll add the super call. This will happen for each type of constructor. I have created two types of constructor here. So first constructor is this where I'm calling this super, and this super is calling my argument constructor. But in this constructor, I haven't called or I haven't add super keyword. So Java will do this thing for me. And because Java is doing this, and now the error is gone from here, but error is coming here because we are calling a default constructor which does not exist. So we have to create a default constructor here too. After creating a default constructor, all the errors will be gone. And now if I run the main, we will get our result properly, and count is 12. So in short, whenever you are dealing with inheritance in Java, whenever you have a parent class and a child class, always make sure that how many constructors you are creating in the child will call super. Either you will call it, either Java will call it, but there will be a super call. And most probably, if you are not calling super, if you are not setting the variables of the parent class, Java will try to call the default constructor. And if you have even a single constructor, just don't forget to make this default constructor or the no argument constructor to not get the error which we got. And with that, we are almost done with the super keyword. There is nothing else remaining in the super. So let's discuss about constructor overloading in Java. What do you mean by constructor overloading? So constructor overloading means having multiple constructor in the same class, each with a different number of types of parameters. We have already achieved constructor overloading here in the dog. In the dog class, we have constructor dog, and there are two constructors which are receiving two different parameters, of course, and this is nothing but constructor overloading. And this is similar to method overloading, but in case of methods, we can make method with different name. In case of constructor, we cannot give it any other name, because if we give any other name, it will not remain constructor. So that's why whenever you have to create one or more than one constructor, we are doing constructor overloading. And here are some key points about constructor overloading that you should remember. Number one, same name, different signatures. All constructor in the same class must have the same name as the class, but they should have different parameter list. Number two, purpose. It allows flexibility in object creation. For example, you might want to initialize object with different values, specific values, or no values at all. In that case, we use this constructor overloading. Is constructor overriding possible in Java or not? So no, constructor overriding is not possible in Java, and here is why. Constructors are not inherited. In Java, a subclass does not inherit constructor of its parent class. Therefore, there is no concept of overriding a constructor in the child class. However, the child class can call parent's constructor using the super keyword. A child class defines its own constructor, but this is not considered as overriding. Since the constructor of parent class are not the part of the child class, we will not call it as a constructor overriding. And after this, if you are asking me what is constructor overriding or what is overriding in general, then I'll give you an example of method overriding so you will get a better idea. What method overriding is, let's say we are creating sum function inside of our sum inside of our parent class. This method is returning 10 plus 2. That's all. So this method inside of the parent returning 10 plus 2. If I copy this same function or method inside of the child class and paste it, now we have the same method name as of the parent. So parent also has the same method, child also has the same method. Instead of returning 10 plus 2, this is returning 10 plus 10. But you can notice they have same name and same type of parameter. Number of parameters are also same. In case of method overriding or constructor overriding, number of parameters makes the difference. But here we literally have no difference, right? So what happens instead is parent's method gets override by the child. And here we are getting something like, hey, this was the parent and that's the child. We generally uses @override annotation in Java to tell Java that, okay, this is by purpose. I want to override some method and this some method in the child is getting override. Why we write override? This is also very interesting. Whenever you do method overriding, you should write @override because this help you from getting into trouble. For example, I wanted to override this sum method, but I mistakenly just misspelled sum from sum to sun, and now we are getting an error. Java is saying method does not override method of its superclass. It is basically saying that sun does not exist in the parent class, so you cannot override. If you remove this @override, Java have no issues. Java will say, okay, Java will treat it as a new method inside of the child class, and Java will say, okay, it is fine. This person is trying to make a new function or a new method. And hence Java will no longer be bothered about whether I'm trying to override or not. If I write @override, I'm explicitly telling Java that I wanted to override a particular method that exists in the parent class. And here is why we are getting an error that sun does not exist in the parent. I can correct it. So after doing this, if I go and if I try to just run the sum method, if I do doc2 dot sum and semicolon, and we should also save the result in some type of variable. Let's say result equals to doc2.sum and print this result. Run this file again. We have 20. So instead of getting 10 plus 2, that is 12, we are getting 10 plus 10 because we have overridden it. We have overridden the sum method and we are receiving the overridden method, or we are calling basically the overridden method. So that was method overriding, which is not possible in case of constructors because we cannot inherit constructors. Animal constructor will not be available to dog class because even though dog is extending the animal and dog is the child, this particular constructor will never be present inside the dog. The sum on the other hand can be used by the dog because sum is a method. Constructor never gets inherited, and that's the reason why we cannot make a constructor named animal like this inside of the child class. I'm inside dog, I cannot do this. I cannot override the functionality of this default method here inside of the child. And that's why we said that constructor overriding is something which is not possible in Java. That's all about the super keyword and constructor overloading and overriding. One more thing I wanted to tell you about constructors, that is how we receive variable arguments in constructors. Let's say right now we have two arguments. I'm passing two arguments, but let's say I want to make a function. I wanted to make a code. I wanted to write a constructor in a way that I can pass n number of arguments here. I can pass 10 names. One dog is Tom, other dog is Rocky, other is I have to write inside, other is Twig, I don't know if this is a name, then Shiro or whatever. There can be n number of name A, B, C, right? How will we receive arbitrary names, arbitrary number of names inside of our dog constructor or inside of this constructor? So we can do this. Let me just remove everything that we have here And let me also remove these two. Instead of hard coding the number of parameters here, what we can do, we can write type, like which type of value we are receiving. What are these values? I can write 3 dots, dot dot dot, and that reminds me of rest and spread operator of JavaScript. Well, anyways, it's a different thing. I can write the name, and this name will be treated as an array. So we have received all these names, and because I have removed those constructors, I can remove this piece of code as well. Here inside of this, I am receiving arbitrary number of arguments using this syntax. And let's just print and see if we are getting names or not. So for that, I'm using for loop, and we have name inside of the names, name in names. It's better if we call it names because we are getting n number of names, right? So name in names, and a simple s out of name will work. Go back to the main class, let's run it again. We are getting all the names. When we use this variable argument, like when we use this particular syntax, it internally behaves as an array. The parameter names is essentially treated as an array of strings. So we can access and manipulate it just like any array in Java. And if that is true, I can also use s out to print the array using arrays dot to string method, and just pass names. Let's see if this works. Run, and we can see, yeah, here we have the array. You can pass either 1, 2 or n number of arguments. If I pass just the Tom will be the only element in the array. So finally, we are almost at the end of this video. We have covered different types of constructors. We have covered a lot of other topics as well, but there is one type of constructor that is still left, and that is the private constructor. So let me remove this animal and this dog, get back to our person class, because here we have a lot of different constructor created. Here I will be making an object of person1 equals to new person, and I think I have to pass the person age and person name. Yeah, I have to pass the age, let's say 21, and the name of the person will be Chitrang. Private constructor. There is a reason why I have included this at the end, because private constructor is special. We use private constructor to restrict instantiation of the class. In Java, it is possible to create a constructor as private, but according to the rule, we cannot access private members outside of the class. What does it mean? If I will create a constructor here, let's say person, and this person will receive a random counter variable, and we are just printing out this counter. And if I make this as private, this is valid, but I cannot use this private constructor outside of this class now, because this is private. This is the access modifier which we have used. If I try to create an instance of, let's say, person2, assign new person, and I'm passing 12 as the counter variable or the counter value, we are getting an error here. Main class cannot find constructor that is accepting an integer value in the parameters. So this is something that makes this constructor very special. It is kind of like a restriction on our class that we cannot make object of person class. Let's say if I make this constructor as private as well, then we cannot even initialize our person1. We uses this in singleton design pattern, but in this video, that's kind of like beyond the scope of this video, and you should not be bothered about private constructor as of now. But I've told you that there is something called as a private constructor, which we might discuss in the future. But yeah, that's all in this video about the constructor. As I've said in the beginning of this video, that we will also be discussing about some interview questions that are commonly asked in the interviews about constructor. So don't worry, you will get all of those questions in the description box itself. Go and check them out. And that's all in this video. Thank you so much for watching. If you have come this far, then do let me know in the comment section. Like this video, subscribe to the channel, and I'll see you guys in the next one. Till then, happy learning.